Welcome to section 4.4, and we are going to be utilizing or using what we learned back in section 3 to answer some real-life problems. So we begin with example number 1. 1, 2, and 3 we're asked to solve the problem. Then 4 and 5 do require the graphing calculator, and so you might want to get that handy. Number 1, we're told the number of mosquitoes according to the June rainfall is shown with this function. And we ask what rainfall produces the maximum number of mosquitoes. Well, we know it's a maximum because the x squared term is negated, so that means there is a maximum. And so h, which is actually the x, will determine the maximum rainfall. So that will be negative b over 2a. So negative 13 over negative 2 equals 13 halves, or 6.5 inches of rain. Number 2, a developer wants to enclose a rectangular grassy lot that borders a city street for parking. And the developer has 316 feet of fencing but does not fence the side along the street. So if the street is going along here, and he just needs to fence like that, those 3 sides. And we need to know what is the largest area that can be enclosed. Well, we need to look at this carefully. Suppose that we let this side be x. Now if it's rectangular, this side would also be x. Then it becomes a problem, how much is available here? Well, we have 316 feet total, but we have already used 2x there. So this would be 316 minus 2x. And so the area of this rectangle would be x times 316 minus 2x, or that equals 316x minus 2x squared. And what we want to do is we want to maximize that area. Once again, we look. It is a maximum because the x squared term is negative. So that means we get maximums. And so how do we find that maximum? Well, we find h, which is actually x. And so x in this case would be negative b over 2a, or negative 316 over negative 4, which equals what? 79? It does equal 79. And so we are asked what is the largest area that can be enclosed. Well, h is 79, or h is also x. So then we can calculate the other dimension, 316 minus 2x. Well, x is 79, so multiply by 79, so that'd be 316 minus 158, which is equal to 158. And so to answer the question, what is the area? Well, the area would be 79 times 158, which equals 12,482 square feet. And so that would be the maximum area that we could enclose. Example 3. You have 112 feet of fencing. We're going to enclose a rectangular plot that borders on a river. We don't fence the side along the river, so we need to find the length and the width to maximize the area. This is basically identical to the exact same problem. I'm going to have a straight river. X and X, however, we only have 112 total feet. So 112 minus 2x. So the area would equal x times 112 minus 2x, which is equal to 112x minus 4x squared. To find the maximum area, we know we need to find x, which is h negative b over 2a, which is negative 112 over negative 8, which equals 28. Oh, it says find the length and the width. That will maximize the area. So this we know will be 28 feet. The other side here, we just need to do 112 minus 2x. Well, x is 28. So that'll be 112 minus 56, which equals 56. And so what would the dimensions be? It would be 28 feet by 56 feet. And that will maximize the area. We know it maximizes it because of the negative here. Now, example 4 and 5 are just a matter of putting it into the calculator and letting the calculator do all the calculations. But it does take a little bit of time to put this stuff in. So what we're going to do is we're going to go to our calculator, and we're going to have to put in some information and then push a few buttons, and then we will get exactly what we want. We are told specifically use a graphing calculator to plot the data and find the quadratic function of best fit. Well, the nice thing about this is it's just, if we can get it into the calculator, it will take care of everything. So what we're going to do is we're going to start, or we're going to go to stat. That's the first thing we need to do here. And we actually need to edit lists. So we're going to edit it as option number 1. Now notice they've got list 1, list 2, list 3. Your calculators may have something in there. What we need to do is we need to get rid of each and every one of those. So what we're going to do is we're going to go to list 1. We're going to go up to the top. So that L1 is highlighted there, and we want to clear that out. So we hit clear and then enter, and that will take care of that entire list if there's anything there. If there's nothing there, then you really don't need to worry about it. We're going to do that for all of the lists. So I'm going to come up here, go to the top of the list and hit the up arrow 1 time so that I'm up there where L2 is highlighted. I'm going to hit clear and then enter, and it clears out the entire list. Now if we look at example number 4, list 1, or the X values, if you call them that, go from 1 through 8. Now there is perhaps a shorter way to do this, but to be brutally honest, it's probably just as quick to do it this way as well. And if we really needed to go much further, then yeah, I would take you through how to make it quicker, but basically just hit 1, enter, 2, enter, 3, enter, and we go all the way up to 8. And if you look on our list now, we have the numbers 1 through 8. Now we want to do the Y values in list 2, and so we're going to just put in the values that are listed there. So we get 200, enter, 205, enter. I'm going to go ahead and do that for the other 6 values as well. 210, 240, 245, 230, 220, and 210. So there we have, in essence, the table that they gave us. We've got that in the calculator. Now, we are asked, what is the quadratic function of best fit? Okay, how we take care of that is we go back to the stat button here, and we have to go over here to the calculate table. So we hit the right arrow key and go calculate, and you look at number 5, quadratic reg. This stands for quadratic regression, which means what is the quadratic function of best fit. So that's option number 5. So I'm going to hit number 5 and hit enter, and then notice it says y equals ax squared plus bx plus c when a is equal to that, b is equal to that, and c is equal to that. Now this is quite a bit of overkill. So I'm going to look and see, maybe 2 decimal places will be good. Let's use that as a general rule. 2 decimal places, unless we absolutely have to go any further. So now we get this value, negative 2.68. We get B to be 26.61, and we get C to be 168.57. And so all we need to do is to go to our calculator, or not our calculator, but the actual work, and we can write our answer, which will be y equals negative 2.68x squared plus 26.61x plus 168.57. And there is the function of the quadratic function of best fit. For number 5, the exact same stuff. We just need to fill in what needs to be filled in, and realize that we have to come back up here to stat. We're going to edit, and then we're going to clear out these things. So we hit the left arrow and up arrow so that we go to L1 and clear it out, enter. Do the same thing for list 2 and clear that out and hit enter. Now number 5, 1973 represents 0, and so actually we get 0 as our first one, and then we have to understand that in 1980 that would be a 7. 1987 would be 14. 1993 would be 20 because that's 6 years further. And then 1997 is 4 more years beyond that, so we get 24. So our list is quite a bit shorter. But now what we do is we go to list 2 and put the appropriate values there. 26.2, 19.2, 16.6, 18.8, and 19.5. And then we can do the quadratic regression once again. So do stat, calculate, and option number 5 is quadratic regression, and hit enter. And so the values become 0.04, negative 1.21, and 26.03. And we'll write that down as part of the answer. But then it says what year corresponds to the time when Americans had the least time to spend on leisure. And so we will, what we would do is we'd put this in for y equals, we'd put y equals 0.04x squared minus 1.21x plus 26.03, and then we would find the minimum, which I'm running out of time. If you have questions, feel free to ask about those in class, but realize we have done that in the past. So with that in mind, just to somewhat complete this problem, number 5, we get y equals 0.04x squared minus 1.21x plus 26.03. Once again, do not forget to find the minimum value, which is also asked. Or you can use the h and the k as well. But like I said, I'm afraid I'm going to run out of time, but we could find negative b over 2a and then plug that in to find the minimum value.